Total solutions for any mix, any volume. All managed by Panasim Enterprise Edition. Panasonic. Total solutions beyond SMT.
Welcome to the VISCOM booth here at SMT Nuremberg. I'm joined by Michael Moog, and we're going to be talking about basically your 3D AOI systems. Welcome, Michael.
Yeah, thank you, Trevor, for this warm welcome, and thank you to the welcome to the audience.
Mm-hmm. Okay, so there's a lot of different 3D systems out there, Michael, but you have got a special edge, should I say, to your system, because you can get a better view of the side view of devices and components. Can you explain a little bit to our audience what you mean by this and how it works?
Yeah. As you know, VISCOM is a market leader in AOI and combined inspection. Combined means inline X-ray combined with AOI as well. And we, in our history, we always had camera modules that were not only looking from the top view, orthogonal view, but also from angular views. So when we took the challenge to integrate the fringe projection and to get 3D AOI, we did it in a way that we do the projection from the top, and we use our up to 8 angular view cameras to acquire the images. And this has a special benefit that we don't only measure the height very accurate, because we have 8 different views where we can detect the fringe pattern. We also have the regular AOI images. And here we have a very nice example showing at the machine. For the video, we don't show a component. We have a dice placed it on the circuit board. And
so if we rotate the dice, we'll see what a typical view would look like.
Right. Let's start with the typical view. As I said, maybe you start with the gray image to show how height information is coded. Actually, you see the dark area is 0 level. The brighter it gets, that is actually the height. So the height is coded in gray. To make it nice, you do a texture. Actually, it's typically it's the picture from above. You put this texture over this height information. Mm-hmm. And the effect is that if you don't have angular cameras, and a lot of our competitors only have the orthogonal view, if you tilt it a little bit, you see you don't have any information of the sides of the object. And so if you present this picture, if there was a component, a very tall component, to somebody who is in charge of doing the defect verification, he would say, this looks strange, I don't want this. I want to take the circuit board, bring it to the magnifying glass or bring it to the microscope. And we want to offer pictures that are genuine, that really show.
So that was very grainy, the one that I saw there when they tilted it. So, so you have a better system for showing clearer views.
Yeah, we actually merge the information that we have from our high resolution, and I talk about microscopic images with single-digit micrometer resolution. We combine this information with this measurement details, the measurement results, and Tino can show now what the effect is. You have a texture, the texture of your sites, which are acquired by our. It's not a calculated library thing. It's really pictures taken by our optics, and now you can even look underneath the component, which is definitely not possible if you do height measurement using this fringe projection method. And this gives a person who does the verification, is this a defect or not? The safety, what I see and what looks real can be determined to be a defect or a false call. And so there we have a real advantage compared to others who don't have this angular view.
Yeah, you've definitely got a lot more definition on that. And so basically the difference is that you're using the side cameras, whereas they're using top camera and they're using just projection on the sides. Is that correct?
The projection is orthogonal, and since with one illumination we can take 8 images at one time, we have a very high speed of 3D image acquisition. That's also compared to others who illuminate from different angles and have to take pictures one after the other. They need much more time for the image acquisition than what we do. And as I said, since we have the cameras there, we have automatically the genuine images, microscopic resolution from the sides. And if you combine both, it's really a nice, realistic presentation to the person at the verification station.
Excellent. Okay. Well, Michael, I want to thank you very much for explaining that technology to us, and we wish you every success as world leader, as you say, of AOI.
Yeah, thank you very much, Trevor, and have a nice time at the show.